Now in today's class, we'll be looking at calculation on isotopes and relative abundancy. Now let's take a look at a few examples. Now number one, say the relative atomic mass of a naturally occurring lithium. Okay, these are the lithium. One has an abundancy of 90% and the other has an abundancy of 10%. So we are asked to calculate the relative atomic mass. How do you calculate relative atomic mass? So now let's write out our lithium. We have lithium 7 and then we have lithium 6. Okay, now the abundancy of lithium 7 is 90%, which is 90 over 100, and the abundancy of lithium 6 is 10%, which is 10 over 100. So you multiply each of them by their atomic masses and then you add them. So this is 90, okay, times 7, then you divide it by 100. So that will give you 6.3. Okay, so we have, for the other one, we have 10 times 6, okay, that's 60, then you divide it by 100, this will give you 0.6. Then you add up the values you got. So we have 6.3 plus 0.6, and that will give you 6.9. So your answer there is A. So that is the relative abundance. Now, so let's look at this other example of calculation of isotopes. Now, an element X has two isotopes with atomic masses of 20 and 22 present in the ratio of 1:3. The relative atomic mass of X will be, now this is given in ratio. Now there are two ways you can solve this. You can decide to change this ratio into percentage, or you can solve with the ratio directly, which is easier and shorter. Now let's convert this ratio to percentage. So we have X 20 and then we have X 22. So the ratio is 1:3. The total is 4. So now this becomes 1/4. Multiply this by 100. Then this becomes 3/4. Multiply it by 100. Okay, let me rub this up so that it doesn't confuse. So from here, this becomes 25% and this becomes 75%. So that is the relative abundance in percentage. So solving on, we have 25 times 20. Okay, 25 over 100 times 20. Then this one becomes 75 over 100 times 22. So if you solve for this, remember you are adding the both of them. So this becomes 25 times 20. Okay, you divide it by 100, you're going to get 5. Now, why for the other, you're going to get, okay, we have 75 times 22 divided by 100, so you're going to get 16.5. Okay, so if you add the both of them, you are going to get 21.5. So that is the relative atomic mass. So if you want to solve with the ratio directly, okay, this is how you do it. So we have, okay, we take for the one with the atomic mass, this is 20 and this is 22. So this is 1 and this is 3. So this becomes, the total is 4, so it becomes 1/4 times the atomic mass 20, okay, plus, then this is 3/4 times the atomic mass, which is 22. So when you solve for this, you are going to get 5, and then this you are going to get 16. Let's look at this. So we have 3 times 22, okay, divided by 4, you are going to get 16.5 for this. So when you add the both of them, you are still going to get 21.5. So whichever method you decide to use, whenever you are given question on calculation on isotopes that have ratio, whichever method, you would arrive at the same answer. Thank you.